My name is Emily Weber, Machine Learning Specialist at Amazon Web Services, and today we are going to talk about multi-model endpoints on Amazon SageMaker. So you might be thinking to yourself, I have hundreds of machine learning models and this is awesome, but how do I serve those in a low-cost, efficient way? And the answer here is Amazon SageMaker multi-model endpoints. Let's drill in. So first, we want to create a multi-model endpoint. And that's going to be really similar to creating a normal endpoint, right? We're going to need a model, we're going to need an image for that. Basically, we're going to point to our image, we're going to point to the absolute S3 path. So multi-model endpoints is going to expect that your models are all in the same path in S3, relatively speaking, which is to say they should all be in a similar directory in some capacity with the same relative reference. And so when you create this multi-model endpoint, you're creating, again, a normal endpoint. You're just going to specify that it supports multi-model, and you're going to point to, again, that absolute S3 path. Create your endpoint config, create your endpoint, and the thing to know is that in this case, your S3 model artifact is only going to make it onto that endpoint after you start invoking it. So it's not going to get copied onto that endpoint when you create it. It is only going to get copied onto that endpoint after invocation begins. So now we need to invoke that multi-model endpoint. So this is an example of using Boto3. Right, we're going to set up our Boto3 client here. We're going to call client.invoke endpoint, and we're going to start with the name of that endpoint, right? So just your endpoint name, your content type, and then the relative path of your model in S3. So essentially that is where that model is going to sit, again, in that S3 path, relatively speaking. We're going to pass in the request body right here. Once we invoke this, right, once we say, okay, SageMaker, use this model, at that point, SageMaker will copy that model onto that EC2 instance. So again, when we're invoking it, that's when model 1 is finally going to make it onto that host. Now, if we start invoking the second model, so if we change this and say target model equals model underscore 2, that's when model number 2, again, is going to get copied from S3 onto that host. And then same thing. So if we switch this out again and get a third model, that third model, in this case the yellow one, is going to be copied from S3 onto that EC2 instance. So that's how we invoke it. And then just remember, we're going to be invoking this relative path here, and then SageMaker is actually going to be handling the rest of this. So that means that SageMaker is managing the memory. It's actually managing, based on the invocation, speed and volume, which models to hold in memory, which models to hold on disk, which models to delete, and which models to copy over from S3. So the reality here is that you can actually save a lot on inferencing costs by using what exactly? And so that's multi-model endpoints. And let's check it out. So in this case, you'll note that I'm actually just on SageMaker Classic. Here I'm just looking at a normal SageMaker notebook. So this is an IPython notebook file sitting on a notebook instance here in US East 2. And the example that I'm pulling comes directly from this example. So if we go back to our home directory, remember this is what your home directory looks like on the notebook instances. We'll cruise up here and we'll hit SageMaker examples. And then we're going to cruise down here, and I'm going to go to, in this case, oops, close that out. We'll go to advanced functionality, and then we'll cruise down here, and then I'm going to step through this bottom one, XGBoost multi-model endpoint, home value, and then you can hit use. But I've already done that, so we'll step this through. All right. Okay, so we're going to make sure that we've got this installed. And then after that, so what we're doing here is we're using SageMaker's XGBoost container the framework container that is. So you may be familiar with what's called script mode in SageMaker when you're bringing a script. What you may not know is that you can bring an XGBoost script and then just run that directly inside of the SageMaker managed container for XGBoost. And in this example, that's what we're going to do. And what we're doing is modifying that script to use what's called multi-model server. And so multi-model server is a framework that's going to let us provide this HTTP front end that's going to implement this additional API. So that multi-model server is over here. And so remember, this toolkit is going to be letting us serve multiple models on a single EC2 instance. Or multiple, if we need to autoscale. All right. So we've got our algorithm name here, multi-model XGBoost, and then this is where we're going to build that container. So here's the ECR image, right? That's configured based on our account, our region, and then we're going to pass in the algorithm name here. We're going to create that in ECR. We're getting the login command here. And then we're going to clone the XGBoost container repo. And then we're going to build the, quote, base container image. And then we're setting up this bdist wheel. And then we're going to build the Docker image. And that's how that works. Great. Okay, so now we've got our image. Now we're going to, in this case, actually generate some synthetic data here. So we're just going to put together some data. And so we've got 1,000 houses per location. And these are all the locations that we're looking at. So again, the reason why multi-model endpoints is valuable, number one is for cost savings, so that you can just use net fewer EC2 instances, but also so that you can solve different problems, right? So if you're solving a problem where you want to expose a single interface to your customers, where they can specify the region, and then based on the region, they can get a predicted house price in that client that you're building, you're probably going to want to hit a single endpoint, right? And in that single endpoint that you hit, you just want to specify which model your customers want to run inferencing against based on the location that they pick. And so that's why we have so many different locations here, because these would be the different aspects of your service. And so we'll just generate a quick price here. So the base price is going to be this function of the square feet of the house. And then we'll set up this price here based on some little function that takes into account the various aspects, return the price. All right, and so we're going to generate a random house just by picking some random aspects here on acreage, garage, year built, all the good stuff. Then we're going to generate those houses. So we're just going to loop through the number of houses we need, add those to a data frame, make sure we've got the columns in there, and then we're done. We've got some generated houses. Okay, so now we're going to train multiple house value prediction models. So we're going to train different models based on the geos. So based on each area that we're interested in, we're going to train a model to be able to tell us what the predicted housing price will be. So we've got BOTA 3 for both S3 and for SageMaker. SageMaker session, execution role, got our account. And here is that image, actually. So that is pointing to the image that we created in that previous step, right? We're still parameterizing this based on our account ID and our region, and now we're just adding in the algorithm name, and that'll work because we just created that image again, and it's now hosted in ECR. And so we're going to prefix these with saying this is XGBoost multi-model endpoint, this is a housing project, and we've got multi-model artifacts. And the training instance here is actually the same as the endpoint. So in many cases, you can actually scale these two separately, right? So even though we're using the same EC2 instances here, you might end up wanting a larger EC2 instance on the training job because you have more data, but then potentially a smaller instance on the endpoint, maybe because you're just running, smaller volumes. So either case is fine here for a demo, but know that you can actually separate those out. And then we're going to split our data set here into train, validation, and test. So this is going to be using sklearn's train test split. The random seed of 7. These are our split ratios here. So there we go. Yeah. Train test split, x1, y1, test size, random seed. And then the same thing for the test. There we go. And then we're going to reassemble these, making sure that the target is in the first column and features after that. So if you're familiar with training models on SageMaker Classic, you will be familiar with that. Note that SageMaker Autopilot actually encourages us to bring a header, and that is so that we can point to the target column there. But just know that when you're training on normal XGBoost, you want to actually drop both the header and the index. Then we're going to run a single training job here for a given housing location. So this is a function, right? And this function is going to be launching a training job based on a location. So we've got our S3 bucket, full input prefix, data prep, and then we're just going to grab the objects that are in that prefix using S3 bucket filtering. And so the local folder is on our notebook instance right now, stored under data. And then we're going to drop that into S3 using session.uploadData with a note here that the training data was uploaded. All right, so then we've got our XGBoost job name, base name here, full output prefix. And then, there we go, S3 output path. So here is that SageMaker estimator. Remember, this is a function that's going to be running a training job. And so this estimator that we're looking at here has the multi-model XGBoost image. We've got our role, we've got our cluster config. So again, one M4 XL, S3 output path, SageMaker session. Then we've got our hyperparameters down here. All the good stuff. Distribution mode. So in this case, we have smaller data sets and we're not actually using multiple EC2 instances. But if we bump this up to 2 or even something larger than that, then we would want to think through this. But in this case, we'll just leave it as is. Training input, validation input, remote, and then fit the model. All right. And so now we are going to run a model training job for each of those housing locations, right? So remember, we had at least 6, maybe more locations that we want to train a model against. And so now we just want to walk through and do that. So this function is going to take a location along with the training data and then just save a local version of that in this local data folder. And then we're going to loop through this. So locations is going to be storing those. So we're going to loop through those. And then we're going to generate the houses. Then we're going to split the data on those houses. Then we're going to save that data locally, launch our training job, and then make sure that job name is appended to our list of training jobs. And there we go. So it's 1, 2, 3, 4. 4 training jobs have launched, which is great. So now in this step, we're going to wait for all those models to finish. Oh, one other thing to keep in mind here is that you'll note that the estimator here has this wait equals false parameter. And so if you want to get back your kernel when you're running a training job, just make sure you pass in this argument wait equals false, and then you can start using your notebook again. It won't just halt it the way it will if you don't have that parameter. All right, but we still do need to wait for those models to finish. And so here's a function just to print out the status of those. There we go. All right, now we're going to import those models into hosting. So this is a function that takes the model data URL from S3 and then is going to return the S3 key along with the model name. And then we're going to deploy those artifacts to that multi-model endpoint. So we're going to describe a training job, etc., etc. And then we're going to copy them over. All right. This removes old artifacts, which is kind of nice. And then we're going to copy every model except the first one, which we do. Great. Oh, we've even got Chicago in there. Awesome. Houston, LA. All right. So now we're going to create this multi-model endpoint. So the model URL, i.e. the S3 path, and then the container, which remember has that multi-model image we built, along with the model data in S3, plus the mode, which here is multi-model. And so we're going to point to that. Then we'll create this model here. There we go. Multi-model name. So this can be a little bit confusing. Remember, we have multiple models here, but in order to create an endpoint on SageMaker, we need just one model. So this one model here is actually a multi-model. And so it's a multi-model that's composed of multiple models, right? And so we're going to point to this multi-model that's called housing with the timestamp, but then this is going to be pointing to that S3 path, and that is how we're going to pass in the extra models. Now we're going to create our multi-model endpoint. So we've got our endpoint config right here. We're going to create that. Endpoint config name. Okay, and then, so this is our cluster config. Instance type using that M4XL. Instance count, etc., etc. So we got the endpoint config, and then we're going to create the endpoint. And then we're going to wait for that to be in service. That's going to take multiple minutes, usually right around 7. And then let's look at this. So now we're going to invoke these models. So this is a function here to predict one house value given the features and the name of that model. And so we're going to use this model to predict the price of this house. So we're going to take those features and then build up a request body. And then we're going to say client.invoke endpoint. Remember, we saw those in the deck earlier. And so that takes the endpoint name plus that target type, full model name here. And remember, full model name is actually passed in here, interestingly enough. So there we go. We'll keep cruising. And then we're going to print this out. All right, so here are the models the endpoint has at its disposal. So this is the AWS CLI, right? We'll just bang that out to list the S3 artifacts in this reference path. So if we want to add models to this endpoint downstream, but we didn't necessarily have those when we created the endpoint, that's actually fine. All we need to do is put that model artifact in the same S3 path and then invoke it. And then SageMaker is actually going to copy it over. So then we're going to loop through our ranges here. We'll grab that full model name. We'll grab the model name. Got it. Interesting, okay. We'll grab the model name, and then from that we'll build the full model name, and then we're going to predict one house value, generating this random house here, minus the target, and the full model name. And there we go. All right, so now we're going to deploy another model. So now we're going to deploy more artifacts. So there's that first one, and remember we didn't deploy that previously. And so we're calling this function deploy artifacts, and let's just review that briefly. Right. So that deploy function is basically just copying that model to S3. So it is making the model available to the endpoint, but it's really just a copy to S3. So not too bad. So we'll copy that over, and then we're just going to invoke it. And so now we'll do another list here. And so there's that new New York model. All right, then we're going to loop through this again, and here is the invocation using New York. And remember, the New York name is coming in from here, so we're grabbing it from that list of locations. So that is going to say New York, basically. Remember, locations we created up top. Locations is right here, and so that's just New York. And then, so we're passing in the name New York here. And then we're going to get the full model name, so that's going to say New York.target.gz. So it has the name of the model here. And then we're going to generate the features on that random house. We're going to pass that in minus the target into prediction, into this predict function. And that takes a full model name. And then this predict one house value is right up here. And this should probably say that, but in either case, given that we're redefining the full model name, it should call that in either case. All right, so some pro tips on multi-model endpoints in SageMaker. Number one is memory management, right? So SageMaker will absolutely, again, manage which models are actually sitting in memory on your endpoint, which models are sitting on disk, which models have been deleted. Your job is to pick the right EC2 instance, size and type that can host as many models as you need in memory based on the use cases that you're solving. So if you're looking at a case where, you're changing model types every hour and you're getting traffic, maybe every couple of minutes, you can go with a smaller EC2 instance. For sure. You should go with a smaller EC2 instance. Your traffic is not aggressive. If you're responding to hundreds of requests per hour, you might, or even per minute, you might want to look at upgrading your EC2 instance and getting something a little bit more aggressive there. And then just remember that, again, SageMaker is going to be managing that for you, but your job is to pick the right EC2 instance. Know that you can absolutely bring your own models here. You are not, again, limited to what SageMaker provides in terms of the built-in algorithms. Definitely make sure you're comfortable with leveraging Docker here and building those custom containers, leveraging multi-model endpoints if you end up going that route. The last thing to think about is that we actually recommend warm start invocations, which is to say when you are launching the solution to your customers, you don't want to introduce any latency to them. And so we're expecting that the first time you invoke a new model on that endpoint, it's going to take slightly more time to respond to it. simply because SageMaker is actually pulling it up into memory from disk on that endpoint in addition to copying it over. And so you want to, again, just make sure that you're actually warm starting those invocations by doing a few on your own to basically alert SageMaker to the fact that you actually need that model right now. So with that, thank you very much. My name is Emily Weber, Machine Learning Specialist at AWS. I hope you enjoyed this video, and I hope you have a great rest of your day. Bye-bye.